Just a little 2-minute warning. We'll probably start in about 2 minutes. So, how's that? That works.
All right, we're going to go ahead and get started. If you're not here for the Rock and Roll Hall of Fame, you can step outside. No? Oh. Sorry, Joe. All right, everybody, this is the DPRIVE working group. If you weren't intending to be here, too bad. We locked the doors. I'm Brian. This is Tim. We're your hosts for the evening, afternoon, whatever. First things first, everybody loves this. I had to put it on 2 slides. Note well, behave yourselves, follow the rules. Read this. All right, so thanks to Chris, Paul, and Dan, we have our scribes, so Tim doesn't have to come around there and beat anybody to get him to do it. And so we can proceed. Here's our agenda for the day. I'll give you 37 seconds to bash it. Is there anything up here that looks wrong? All right, so let's get started. Document status, really quick. The DTLS and TLS profiles are in Auth 48. Technically, it's actually in Auth 48 done. I can tell you notionally what the RFC number will be. It should be out pretty soon. And as of this morning, our AD put the padding policy document into IETF last call. Any questions on the document status? All right, excellent. So turns out that Sarah is not feeling well, so we have a guest speaker who's going to talk about the DNS privacy BCP. Roland?
Okay, thanks. Yeah, Sarah asked me to stand in for her. So any mistakes are mine, and she made really nice slides that I make stupid mistakes about. And Sarah's going to be online on the Jabber. So Dan is probably going to jump up and correct me if I say something completely stupid. So Sarah has been spearheading a draft with recommendations for DNS privacy service operators. Alison Mankin, Benno Overeiner from Manila Labs, and I are co-authors of that draft. And this is really a first version, and we want to talk you through sort of our thinking as we were writing this up. To give you a short overview, the document is currently about, say, operational policy and security considerations for operators that offer DNS privacy services. And we haven't necessarily limited ourselves to DNS over TLS, although that has sort of been at the back of our minds. And it should also be a framework to assist people in writing a DNS privacy policy and practices statement, similar to a DNSSEC practice statement that already exists as an RFC, and it helps people sort of write up how they do their key management, how they refresh their signatures, what kind of data they accept in their zones, etc. So the status of this draft is that it's very much a draft, right? It's full of to-dos. We submitted it here to get some initial round of feedback, and as I was sort of going over the slides to know what I had to tell you, comments were actually coming in, so we've had some feedback already. And one of the questions that we're going to ask at the end is whether this is something that people would want in this working group, or whether it would be better placed somewhere else. It could be, for instance, in a RIPE BCP track. And we've had some feedback from Stefan as well, and I'm going to channel Sarah and say thank you, Stefan. Now, there is some existing implementation guidance. If you run DNS over TLS, there is the profiles RFC 8310 just out. That has some musts and some shoulds. So the musts are to follow sort of TLS best practices, some things about TLS session resumption, broad public keys, etc. And there are some shoulds in there about whether or not to use EDNS zero padding, and to say something about EDNS zero client subnet. There's a question already.
Yes, Francis Dupont from IC. I have concern about the should for ECS, EDNS zero client subnet. It kills the performance and kills the caching, which is pretty bad for privacy.
Yes, completely agreed. So we are actually, we were discussing this. So we discussed it about the four of us this Monday, and ECS is one of the things that came up. So
is it a should not?
So we haven't got anything in our draft about it yet. And I said there should be something in the draft, and it probably should be, well, at least you should be transparent about whether or not you do it. Whether it's a should not, I don't know. We can discuss. So to be clear, this is not what is in our draft, right? This is the existing implementation guidance, Francis. So, and then some bits and pieces from the DNS over TLS RFC about public key pins. Now, we needed to sort of find a definition for a DNS privacy server. And we sort of came up with what is in the green box, which is that it is a service offered via a privacy-enabling DNS server, and that there is some sort of document that has an informal statement of how you as an operator handle people's data if you run this service for them, with this particular focus on privacy. And there could be a formal practice statement that has some sort of structure like a DNSSEC practice statement does now. If we look at operational guidance that we have in mind, then this is about things that, like server capabilities that maximize DNS privacy, right? So there's a should for things like queue minimization, connection management, not to require TLS session resumption, and things along those lines. And certainly something like EDNS client subnet is something that needs to be considered there. There's a question.
Ted Hardy, it may be worth looking at the port recommendations and distinguishing between port 443 for TLS and port 443 using this over DTLS, because there's a much larger chance of, I think, some potential issues with QUIC being demuxed onto the same port there. So we may want to look at that guidance and make specific guidance for 443 TCP and 443 UDP.
Okay, thank you. Yeah. Well, 443 is going to be discussion anyway with DOE, so.
Dan York pretending to be Sarah. To clarify, the draft IETF deprived DTLS and TLS profiles has passed Auth 48, but is not yet published. In that draft, the guidance is that recursive should honor a client request to not send ECS upstream.
Right. Oh yes, thank you, Dan, for channeling Sarah. That's very much what we discussed. So if there is this EDNS client subnet option as a client, you can request that your data is not forwarded to any authoritative upstream by setting a /0 scope in the request to your recursor, and the draft very much says that you should honor that. I think, well, at least the implementations that I know of do that. Yeah. Sorry. Yeah. Anyway, any mistakes are mine. Then there is the May, I guess, which is what the question was about, whether you should also run a service on port 443 for people for which port 853 is getting blocked. But then you get into a discussion at some point whether or not that's going to work in the presence of DOE. So that's something to keep an eye on. And there have been some suggestions that you could run both things simultaneously, and that would lead to something really horrendous. So no. Then you could have a route zone on loopback. Of course, that ensures that your when you do a recursion, that you're not going to be exposing some of your traffic if you have an empty cache to getting sent to root servers. And you could also be using aggressive DNSSEC validated cache stuff, the NSEC, aggressive NSEC thing, where if the recursor can synthesize an NX domain for you from NSEC data that it already has available, that saves you an extra query going to somebody who then learns that you're interested in something in their zone that doesn't exist. There's been some debate about client query obfuscation for very small deployment, where basically users can still be very traceable because there are very few users using a single recursor, where you would mix in other traffic to sort of obfuscate a client traffic. We haven't really had time to debate whether that makes sense or not. So Sarah asked me to remind you that this might seem obvious, but we're going to include recommendations about certificate management, because that is where things have been going wrong operationally now. Certificates almost expired and things going wrong. And it seems so obvious, but this is something that people need to take care of when they're operating a DNS privacy server. And we're not quite sure yet what the best practices on that are, whether you could, if you reuse your key, you have the same public key pin, but does it make sense to reuse your key? That might not always be good practice. So that's something that we're very much thinking about yet. And obviously you need to monitor whether your certs expire, right? Especially if you have certs that are in there, they're going to be lasting multiple years. I personally have configured DNS over TLS on our operational service at my employer, and I generated certificates that were just valid for 10 years because this was experimental, but I just put notes in my calendar to remind myself that I need to check those certs every year or so. Another thing on operational management, we want to discuss what the limitations are if you use a TLS proxy and then send the traffic onto, say, an ordinary DNS recursor over TCP. What happens in the case you have Anycast? That is still blank in the draft, but is something that needs to get discussed. And I hope that Sarah is going to channel through Dan if I say something that was already in there that I forgot about. Now, data handling, this is something that is sort of closer to my heart. It's something that we've been discussing, and this is about if you do DNS over TLS, you're solving one problem because you're protecting people's privacy on the wire as they communicate with their recursor. But then the operator of that recursor still can do a lot of stuff with the queries that are coming in, right? They can do logging, monitoring, etc. So a lot of the focus in the draft is going to be about what you do with that. And you can decide to minimize or anonymize logging and monitoring, but there might also be valid reasons why you are looking at certain traffic, because you want to, for instance, detect whether there are malware infections in your network or other indicators of compromise. And after this, I'm going to talk a little bit about how we're sort of doing an experiment with a technology that sort of does some privacy preservation there, to see if we can do this in a privacy conscious manner, where we achieve some of the goals of detecting stuff without actually storing everybody's queries. Then you need to think about, if you're storing data, what period are you storing that data for? How long are you going to keep it unanonymized? When are you going to anonymize it? Who has access to that stored data? Are you going to be using it to track users or not? And are you going to share it with third parties? And in both cases, we're saying, well, you shouldn't be tracking users and you shouldn't be sharing this data with third parties. And right now, very much is unclear about things like Google says, well, we're not going to share that data if you use Google Public DNS, but is that the case? Well, I mean, one department of a huge corporation that talks to another, is that sharing or not? And that also sort of ties into who has access to stored data. Some of the things that we've been discussing is, how do you, quote unquote, pseudo anonymize or do other sorts of de-identification on the data that is that you're recording. There was a talk at the DNS privacy workshop at NDSS last month from Bert Joubert. I don't know if he's in the room. Yep. About IP cipher. If you haven't seen that, I recommend having a look at it. The Bloom filter thing I'm going to be talking about next, so I'm not going to go into detail here. But we're very much open to other suggestions. So people that have suggestions on how you can have some logging facilities, but ensure that not all your users are visible and that anymore are not visible anymore after some time. That is useful information for us to have in this draft. Then the DNS privacy policy and practice statement, the DPPS. The idea is that you, in terms of policy, you specify things like what data are you collecting, how long are you keeping it, is it getting shared, what are exceptions, what are third parties that have access to it, and whether you're doing data correlation between this data and other data. This is something that people that have to comply with GDPR, and that's probably pretty much everyone, will have to think about anyway, right? So it's worth thinking about, and we're going to be thinking about providing some guidance in the draft about this, how you set this up, how you write up your policy around that, and that might even be useful if you have to comply with GDPR anyway. Now, in terms of practice, how do you deal with temporary or permanent deviation from your policy? How do you communicate about this? What kind of capabilities are you providing on certain addresses or certain ports? If you look at, for instance, the operators of Quad 9, they filter some traffic if you use our Quad 9 address, but where they filter out, say, what they think is malicious, are malicious names, but they have a secondary service that they talk about that does not do that filtering. And we are thinking about whether we need to mention in the draft whether people should specify if they do this or not. Maybe it's not privacy, it's some form of filtering or censorship or whatever, but there seems to be a relation and we're not quite sure where that should go yet. And again, EDNS client subnet usage, right? Quad 9 again has a statement on this where they say if you use our main Quad 9 thing, we will not do EDNS client subnet, but they have another one where I think the unfiltered one does do EDNS client subnet. And they're transparent about this. And this is something that's important, right? People should be transparent about what they do. And in any case, and I'm going to so correct myself, they must respect clients that request that their information not be forwarded in an EDNS client subnet extension. And other things are in our authentication credentials. How do you know that this is the correct DNS privacy server that you're talking to, and contact and support information, obviously. I think this is the last slide. There are, it's going to be tricky if you write a practice statement like this to somehow have technical solutions to validate whether people are sticking to this policy or not, right? There are some things that you can check, right? Things like EDNS client subnet, you can probably check if they're sending this to someone. There are test services for that. But whether or not your queries are getting stored, you're sort of have to going to take the operator at face value for that, or you're going to have to go there and ask them or send them a data access request again, this might be something that GDPR might be useful for, because if you're an EU citizen, you can now start asking companies what they're storing about you, and they have to tell you, they have to comply with this. But whether or not that's going to scale, if we have enough privacy nuts to actually start sending these requests to operators, I don't know. I plan to send one to Google, just out of, I mean, I want to know. So what it really boils down to is, are you, if you have such a policy, is this a trusted service or is this a trustworthy service? And given that you can't check everything that is there, probably trustworthy is a better term, right? Because if they're being transparent, then you might sort of give them the benefit of the doubt, and you think, well, they're worthy of my trust, so I'm going to use that service because they're transparent about what they do. Whether or not you can make claims about whether a service is trusted or not, that's very much up in the air, and it seems unlikely. So we come to the end with the questions for the room. One of the things is about the scope of the document. Should we have a section in there about authoritative servers or not? About what they do with queries that they get in and data that they store on that and analysis that they do on that. Whether there should be exemptions or special provisions for research data. There are lots of people that do useful research on DNS query data. Do we somehow need to recognize that in the draft? And then there are questions about the generality, right? During the talk, I already mentioned the GDPR a number of times. Many of the issues that we're discussing in the draft seem to be somewhat generic in the sense that they are actually included in the GDPR, but it might be useful to have specific guidance for people that are operating such a service, right? So that will be the focus of our draft. And then whether there should be something in there about filtering or not, like I discussed before, and Sarah, if you're listening, correct me if that's not what you meant by saying filtering, but if you are doing this, whether or not you should mention this, is that something that is within the scope of this draft, or is that something that's outside of the scope of the draft? And finally, it's about our approach. So the approach is currently very prescriptive with RFC 2119 words like must and should, or which can be useful, but we could also go for text that is much more discursive and says, well, if you're in this context, you should be thinking about doing this. If you're in this context, you should think about doing this. And then it turns much more into a checklist that says, if you're operating a DNS privacy service, you should have thought about at least these things, and here is some guidance on what you could do, but it would be less prescriptive, and we're open to suggestions on whether to go one way or the other. And before I go for the question, the last obvious question is this something that people feel that should be part of this working group or not? And Dan's going to channel Sarah.
Just to say, no correction needed. That's what she meant.
Okay, excellent, good.
Ted Hardy, really a point about the approach. There are a couple of places in the document where you recommend a very specific answer to what turns out to be, in fact, a particular mitigation against a particular threat. For example, you recommend that in certain cases you run a .onion node. And there are other approaches to doing similar things that would not involve you running a .onion node. And so a more discursive, more contextual approach would actually be helpful for you to pick other options, in particular if you have reason to believe that one approach that you might have in the draft later turns out not to have the privacy characteristics you expect because of compromise or some other issue.
Yep.
I also would really appreciate this having sort of a ranged approach, although I think it's very, very useful to have, hey, if what you're trying to do is to provide a DNS service with the specific goal of providing a DNS privacy service, it's also the case that it would be really, really nice if people just turned on some of the transport level confidentiality capabilities on enterprises and other things where it's not the case that they're providing a DNS privacy service, but using the facilities of DPRIVE just in the course, as you say, of normal DNS. And so having a bit of a ranged approach to say, hey, if you want to provide confidentiality over the wide for your enterprise customer or your radio network customer or whatever, here's the minimum thing that you can do. If you are constructing a service that is intended to provide privacy at a greater level, here are the things you should be thinking about. And if you're providing DNS service, even without all of these things, you may want to think about some of the data handling practices because they may be required in your jurisdictions.
Okay.
Although, honestly, if you're going to write a primer on how to handle the GDPR,
No,
more
no,
power
no.
to you and Sarah. I Lord love you for taking it on. Thank you very much. But really, I think a little bit more contextualization would really expand the utility of the document, and it would really encourage me to say yes to the final piece.
Okay, thank you. Stefan.
Stefan Bartsmeyer, I think the good thing about a very prescriptive approach is that it makes writing the policy statement or data privacy practice much simpler.
Yeah.
If you have a threat analysis, detail, options, etc., it's much more complicated to explain this in the data privacy statement. But I wanted to talk mostly about the choice of the forum for the discussion. You mentioned the WIPE, for instance. I think that today, there are very few people who have actual experience with a DNS privacy server. It's something very recent, and I guess that most of these people are in this room. I don't really see outside of IETF who can have the experience, because if you want to talk about best practice, you need some sort of practical experience before. So today, I think I don't think there is a best place than this group.
Right, okay, thank you. Yeah.
Back mic, yep.
Right. So my name is Amelia. I come from Article 19. I had a couple of questions on this.
Thank you for your feedback before you start. I just got the email from Sarah, but yeah.
Okay, right. So those were the things that I wanted to bring up in the group as well, that I think the terminology that you used in the draft is not really conformant with RFC 6973. And I like auto-referentiality in documents. So I propose that you use like pseudonymization instead of pseudo-anonymization. But then I'm also wondering why you make a distinction between logging and monitoring and data retention. Because to me, data retention, much like GDPR, is quite closely connected to policy debates in Europe. And data retention means that you do logging, or it's logging for the purpose of monitoring in the European legislative context. But I'm wondering if there's a technical subtlety here that I'm missing.
So there are some provisions at least in GDPR, there are some provisions about data that is in memory for a very short time, right? If you're operating a router, then you're processing personal data, but you're not storing it. And there are some provisions in there for handling that situation. Equally, so yes, you're right. So logging and monitoring and data retention somehow have to do with each other, right? Logging is, if I have to say, logging is probably something that you do to be able to see why something went wrong in the past. Monitoring is something that you do to see if there's abuse on the surface, or if there's other stuff that needs your attention immediately. So that's sort of guaranteeing the continuity of your service, safeguarding their security. And logging is something that you look at after stuff has gone wrong, right? So there's some subtleties in there.
And so,
no.
But so also as a final point, I could say that in the GDPR, and I come from the European Union, and I've worked with the GDPR for some years. There is this section that talks about state-of-the-art technology. Privacy by default is the state-of-the-art technology. And so effectively, I guess, what would be defined by this group in an IETF concept could actually itself be used to define what the legal obligations for privacy protections are in Europe. Since the law refers to the state-of-the-art technology, if you produce a draft standard here or an RFC or recommendation, that could itself influence what is the expected level of privacy in Europe, and that might be valuable information for this group to take into account if it goes forward with this process.
Okay.
So,
well, that's a very good comment, and also puts a huge burden on our shoulders. But yeah.
Stephen Farrell. So I generally would be supportive of doing this kind of work. I think I agree with Stefan that it's hard to say where else you could do it. I would have a little concern that maybe we are a bit early for PCPs on this. I think it's no harm to start the work, but I don't know that we have great amount of actual practice to rely on. And one thing it might be worth thinking about, to what extent do you want to include things that are a bit more speculative in here, like maybe the Bloom filter, things that are mentioned Or maybe they should be handled in other documents or at other times as opposed to in this one document.
Well, and thank you for the comment and for the support. I mean, that's also why this is. We somehow want this to be a living document, which can be a bit tricky, which is also why we're openly asking the question to the room, is this something that should be here? Should we consider doing it as a RIPE document, which might be more of a living document? And yes, it might still be quite early to do something like this, but the DNSSEC practice statement RFC was also at a time when very few people were doing DNSSEC. And so having some sort of framework that helps you sort of construct your privacy service might be useful. Anyway, Jim
Reed, pretty much what Stephen said. I think some of the things here are premature. I also think that trying to come up with a complete overarching potential policy framework discussion in an RFC or some other kind of internet document in this working group is going to be a very difficult job, but I think we might as well be trying to boil the ocean. So my suggestion, for what it's worth, would be to first of all start by getting some of the people that are deploying privacy services to document some use cases and say, these are the things that we thought about when we launched this service, and these are the problems that we encountered once the service was launched, when the Data Protection Authority started knocking on our door and saying, or peering over our shoulder and asking questions. I think that'd be a better place to start, rather than trying to find an overarching solution for everything, which will probably never terminate. And to what you were just saying before, Roland, with the DNSSEC policy statement, that was a relatively simple, easily constrained problem space by comparison. So it's relatively easy to do. Simple matter of programming, right? But in this context, what we're trying to achieve is much, much more difficult. There's a bigger problem space. It's much more rapidly moving in all sorts of different contrasting directions. And I think it's probably very, very difficult to try to come up with something which encapsulates everything, unless you end up with something that's so generic it's completely useless.
Yeah. Okay. Thanks, Jim.
All right. I'm going to cut the mic line to TKG.
Peter Koch-Dienig. So I really like this document. It's a very good, very, very good starting point. I have, I'm not sure about the target audience and whether there is a single one, because you already mentioned that there's the part that would address the potential provider of a privacy service, and somebody else already said at the microphone that the considerations may also apply to a random resolver operator. Whereas the other part, the privacy statement or privacy practice statement, so to speak, would probably address even an end user, and that needs kind of different skills and different language and so on and so forth. I am not sure, actually I'm sure that not. The IETF should engage in policy discussions or debates, especially if it goes along the lines of what is in the GDPR, and not because we have other jurisdictions, and whether or not they follow the example of the GDPR, that is probably something that will never end.
Yeah.
So in a updated version, I think that there could be a split of documents by target audience, and then avoid for the operators, for the IETF part, avoid the policy definitions, which does not mean avoid the enumeration of policy options, but not the recommendations in certain directions. Like I especially had issues with the .onion, for example, that doesn't really have a place in there in my opinion.
Yeah. So just to clarify, ask for a clarification. Would you think that if we were to go for a more contextual or discursive way of writing this document, that would address some of those concerns? Because it would be, I mean, making it less prescriptive and more of a, these are the options that you have, this is what you can do. If you're in this context, you should consider looking at these options if you're in this context, rather than saying you should do this, you should do this.
So yeah, that's probably it. I had a bit of interference here, so I couldn't really completely understand what you said, but we do have the privacy considerations in the DNS, but that is not specifically focused on the perspective of the resolver operator or the user of a resolver only. So focusing on that might be a good starting point. And then for the policy part, I think another venue might be better. I don't know which one, but I'm as I said, I'm pretty sure that the IETF would be the wrong one, despite what Stefan said, that people would have to be educated about the technology. However, we do have human rights people. Well, we did have human rights people here in the room, which is great, but more of them, and data protection practitioners and so on and so forth. We need that. On the scope, and of course, being partly an operator of an authoritative server, I don't like being in the scope of this. No, seriously. No, that's not the point. I was kidding. I'm sorry. I think that makes little sense if you talk about the server, because many zones are served by servers in different jurisdictions and under different management, and getting that out as a statement of the zone owner might be more important. But then again, who's going to read that, and for whom is that important? That's a completely different issue. Actually, you defend against some of these things by the measures that you suggest in this document. So keep the good work. Maybe split this and make sure that you engage with, and we can talk offline, engage with other people that might be more focused on the user side to get the language and the details a bit more crisp for user consumption. Thank you.
Okay, thank you for your input.
So Warren, Kamari, both relaying a comment from Jim and my own. So firstly, various privacy organizations or agencies view the GDPR differently. And so it's sort of the GDPR viewed through a lens, not the GDPR. Did I cover that well enough? Okay. And then also following up from what both Peter and Ted sort of started saying, I would really like this technology to be widely deployed. And I'm kind of concerned that people who look at this document are going to assume that unless they're doing this specifically for privacy, they shouldn't bother doing it. And so I think it needs to be clearer that, even if you're not a privacy DNS resolver, turning this on because it's a good thing to do is, a good thing to do.
That's a good point. We actually had that discussion already, and it's,
This is DKG. So thank you for working on this. I do think that this is worth pursuing. And I think this working group is a reasonable place for it, including the policy section. I think the policy section is going to be tough, but I think that coupling it with the discussions about specific technical measures is worthwhile. A couple of technical points. You mentioned IPCipher or IPCrypt in the draft. I don't know if you followed the discussion on CFRG. It looks like there are some significant concerns about IPCrypt, and so we should probably take care of that. As far as I think Stephen was saying, we need more practice before we can get to best current practice. I don't have any problem with documenting the best current practice from a small pool of current practice. If it causes other people to start practicing and saying, hey, we've got better practice, we'll make a new draft, right? So I think making sure that those of us who are currently trying to operate services like this get together and encourage each other to make better practices by documenting them, I think that's a very valuable thing to do. And we do not need to wait another year to do something like this. Let's start the conversation, and we'll change it later if we need to. One thing that seemed like it might be missing from the draft is any question of, you've got padding in there in terms of, that's like the only piece of traffic analysis, anti-traffic analysis or traffic analysis countermeasures that you've got in there. And I wonder whether there shouldn't be some section on aggressive prefetch as a means of, and we can talk about this more offline. But I feel like something about aggressive prefetch actually has both optimization wins and potentially privacy wins.
No, it does.
So it's nice to have these
and
pairs.
it's also something that at some point it came up in the discussion. I don't remember when we talked about it, but it is a good idea. Yeah, thank you.
All right. While Tim gets the slide switch over to the next talk, I just we're both interested in seeing how many people actually read this document. All right. How many people think this is actually a document worth working on regardless of the venue? Great. Thank you very much. Oh, and you're up again.
Oh, yeah, but this time it's my name on the slide. So if I make mistakes now, it's even worse. So I asked the chairs for a little bit of time to talk to you about an experiment that we're doing at Surfnet. So Surfnet is the National Research and Education Network in the Netherlands, and they're my employer. Privacy is a value that we hold really strongly within the organization. So that's why we're involved in the DNS privacy area as well. So we run some of the servers that you can use today, the DNS privacy experimental servers. And one of the things that we thought was, well, okay, can we do something about this collecting query data? Because we are, as an operator, we want to know if some of our colleges or universities are getting hit by, say, for instance, some indicator of compromise, there's some malware out there that we can recognize by looking at DNS queries. How can we do this without sacrificing user privacy? And this is one approach that we have. I'm going to go and talk a little bit more quickly about this because I have only 10 minutes. So this is our main question, right? How can we detect if certain DNS queries were performed while respecting the privacy of users? And what we did was, I was talking about this to a Dutch company called QuarantineNet that's very active in our community. And they have some sort of detection apparatus that will detect if there's malware in your network. And they were looking at this using Bloom filters for this. So I'll explain what Bloom filters are. And we're now starting to experiment with this in practice. We're going to run this against our operational DNS recursors and see if we can use this as an alternative to registering queries. Hands up, who knows what a Bloom filter is? Wow. Okay, good. So should I skip this slide? I know, I'll just, I went through all this trouble to make really nice pictures about it. So think of a Bloom filter. So a Bloom filter is something that was originally designed in 1970. It's as a space-efficient way to index large amounts of data, right? So if you have to find your way around a database, if you do a query in a traditional database, say like Postgres or MySQL, then odds are that they're using a Bloom filter to work out whether the thing that you're looking for is actually in that table or not, or in that column or not. Because it's a fail-fast way of looking up data in large data sets. But if you take a step back, you can think of a Bloom filter as a probabilistic set membership test, right? You have this unordered collection of data that you keep cramming distinct items into, and then you can ask that a question: is this element that I'm now looking for, is that in this data set or not? And if the filter says no, it's not in there, then it's guaranteed not to be in there. And if the filter says yes, it is in there, then there's a small probability of a false positive depending on how you configured your filter. So how does it work in practice? You take a domain name, say here www.example.com, you run that through a hash function or a set of hash functions, and then you use the output of that to pick a number of indexes in a bit array that you then set to 1 if for sort of the specific values that came out of the hash function. And then if you want to do a lookup, you run the lookup that you want to do through the hash function again. You compute the indexes that should be set to 1 if this element is present, and then you look in the bit array whether or not that element is present or not. So the picture shows 2 examples of things that hash to different array indexes. And then you can also immediately see why you might have a false positive, because some of the bits that are hit by one name might be set because there are some overlaps in other names that trigger those bits to get set. So there are a certain number of things that you can tune about one of these Bloom filters. That you have to pick the size of the bit array, the number of hash functions, or the number of indices in the bit array that you're going to be toggling, depending on the outcome of the hashes, and the expected number of distinct elements that you're going to be putting in there. And then if you stick all of those parameters in this formula here, you can sort of calculate the probability of a false positive. And I'm going to save you the trouble of doing all the math. If you pick a reasonable size bit array, say 60 megabytes or 128 megabits, and you cram a few million queries in there, you have a very low false positive probability, which means that this is actually a really nice way to be able to detect if a query was executed. Now, using this kind of technology in a privacy context is really interesting because these filters don't store the original query names, right? And they're non-enumerable. Because I'm not storing, if I were to store queries as the hashed query name, then I could still presumably, with some knowledge of the data that's going to be in there, reverse engineer what query was performed when, what query it was, and somehow reverse the hashing with things like rainbow tables or just brute forcing it with GPUs. But that's just simply not possible with this. If you sort of mix enough queries into that Bloom filter, you don't know what the original hashes were. There's no way to reconstruct that. And if you mix queries from multiple users, tracking users is going to be become increasingly hard. There are some exceptions to that, though. Another nice property of this technology is that you can later take the bit arrays from two filters, and if they have the same parameters, you can combine them into a single new filter that has a higher positive probability, but you have all the data that was in the two filters combined, which is really useful. Because, for instance, say we want to collect one of these filters every hour, then we can aggregate at the end of the day and still know roughly with a slightly higher false positive probability what queries were executed during that day. And that allows for a gradual data aggregation. Now, there are some other considerations. There are some privacy risks, right? If you know of a query that unambiguously identifies a certain user, you can still track them. Say I record a query, collect a filter once every hour. I can still, if I know that some user is always going to this one site that only that user is going to, and there's a DNS query for it, I can check if that query was in that filter or not, and know that that user was active at that time. It is almost impossible to correlate it with other queries for that user, though. So you will simply know whether that user is active or not. So whether that's serious or not is something that you need to think about, but that is one of the risks. And of course, there are additional benefits. This is way more space efficient than storing all the DNS queries, because these filters have a fixed, reasonable size, and it is time efficient. Lookups are fast. So I think I'm going to skip over this. So maybe a little bit about this picture. What we want to do, so we run a network for like academia in the Netherlands, right? That means that we have roughly about 200 institutions of higher education and research on our network, about a million and a half end users. We want to use data that we collect on the resolvers sort of strategically and tactically. So we want to be able to say if we have this indicator of compromise that says that there is a very serious breach of security, we want to be able to say which institution was hit. We don't really care anymore which specific user that was, because that is the task of the individual institution, but we want to be able to say they were hit. So we're going to be aggregating, or at least that's our current thinking, users from certain networks into certain filters for that. I have a master student working on this who is going to be sort of designing a system that not only collects the data but allows us to query the data. We're going to deploy this in practice on our busy resolvers. I'm not going to bore you with the details. You can look at the slides in the materials for the session. The master student will be looking at 3 particular use cases. So we get indicators of compromise from our National Cybersecurity Center, and they come through the intelligence services. So they claim that these are sort of serious things that we should be looking at. And currently we have no way of looking at DNS data for this because we don't want to store query data. And this gives us a way to do that. We have a particular issue that young students in our network seem to think it's a good idea to DDoS their institution if they don't want to go to class. And we want to know if they use booters for this. And we thought it would be interesting to see if our mail filtering service hits certain names on blacklists, whether those names actually get resolved by other people as well in the network. I think this is the final thing I want to say. The Bloom filter library that was developed specifically for this purpose, we funded the development of that as an open source solution. So we're going to be releasing that under a BSD license. And we also funded an Elnet Labs to somehow do some integration with Unbound so that people can start experimenting with this. We're expecting to release that code somewhere this year. We don't have a definitive date yet. That's it.
Right. Got time for 2 quick questions.
Hi, Alex Mirova here. In that implementation that you did, is there an option to dump the Bloom filter into a file and reread it from that? Because
yes, there is. Yeah.
Okay, cool. Yeah. Because what I lack in Bloom filters is, let me put it that way, a portable format to actually transport Bloom filters from A to B. Because I'm never quite sure is that big endian, little endian, yada. So
yeah, that is in there. Yeah.
Okay.
Yeah.
Cool. Thanks.
Hi, Edward Dean. This is really cool. The one problem that you might have is the Bloom filters lose the cardinality of events. So while you can detect that it has occurred, you don't know how many times. Is there anything that you're looking at to consider that as part of the design?
So yes, there is. So there are options. One thing that you can do is have multiple filters side by side that have different, that use slightly different hash functions, for instance, by pre-salting them. And then you enter your data into separate Bloom filters. You can then combine them to see, to get some sort of cardinality. There is such a thing as a counting Bloom filter, but we're not using that for the moment. It's not, so we are actually from a strategic tactic point of view, we're really interested in whether a query occurred and not necessarily how frequently, because whether a query occurred is then probably going to be a trigger for we need to look into this more, with much more detail, and then how often it occurred is going to be the next thing to look at. Does that answer your question?
Yeah, great, thank you.
So Dan York, relaying for Mukund from ISC, and he said, from the presentation, it is unclear how the author intends to use Bloom filtered names, especially for checking if some query was performed before, because there's no guarantee for lack of false positives. The Bloom filter might tell you that someone.example.org was queried when it was not.
Yeah, so this is something that I think what Mukund is referring to is the risk of a false positive. And this is something that we actually want the student to look at. We don't mind so much that there's a risk of a false positive. What we want to know is what is the impact of a false positive, right? Because for the parameters that we're going to be using, the risk of a false positive is like something like 7 times 10 to the power minus 7. So that's a very slim chance. But if we're going to be basing a decision to actually start inspecting traffic on a hit in the filter or not, then a false positive has a much larger impact on privacy than you might want. So that is something that we need to take into consideration. I hope that answers this question.
Hello, Christian Wittemer. That's a nice idea, nice presentation, but I'm a bit worried whenever I see things that are based on hashes, because a Bloom filter is effectively based on hashes. I'm worried about the attacks on hashes, in which the specific names, for example, of botnets could be chosen so that they collide with other names or combination of names in your botnet, so in your filter, so they hide.
That's a really interesting premise. So actually in this implementation, we're using, Quarantinet is using SHA-256, which to my knowledge at the moment is still collision resistant.
That's true, but you're using SHA-256, then you're taking 8 buckets, and you're taking each of the bucket, you're taking the modulo, I don't know what in it. Yeah. So it's...
I'm sorry to cryptanalyze at the mic, but you can use a private salt for the folks who are building the Bloom filter and avoid that.
Yes. And that's right, yeah. Okay, thank you for your time. Thank you. Stefan.
Okay. Hello, everyone. So, as you know, the charter of DPRIVE expressed the idea that we will work first on the stub resolver to resolver link to secure it, to make it more private. With adoption of, with the approval of IETF, of padding policies, of TLS padding policies, I think that this first part is done, so we can congratulate ourselves. We managed to do everything which was in the charter. Now it's time to think about the future, and mostly about the resolver to authoritative link, which creates some interesting challenge. I already wrote a draft about the possibilities for this resolver to authoritative link with a lot of different possibilities. Apparently, there was very little discussion, so I decided to do instead a specific proposal with a specific solution for the resolver to authoritative link, and I would like people to discuss it now. So the idea is, of course, to use DNS over TLS. DTLS doesn't seem to be used a lot up to now. So DNS over TLS, which means TCP, RFC 7766, etc. And the big problem, of course, with a resolver to authoritative link is authentication. A stub resolver talks to only a few resolvers, sometimes only one. So you can have static configuration of credential. A resolver talks to a lot of authoritative servers. So you cannot have static credentials. You need something else. In my opinion, the best solution is DEN. It's something that DNS people know. It works. It's already used for the web. So it can be used also for authenticating authoritative resolvers. This is described in this draft. Read it, comment it, etc. There are a few questions which are still open in the draft and which I would like input from the working group if people are interested. A good thing about DEN is that it's a signal that the server supports this protocol. So in theory, with DEN, you don't have to probe the server. You know that it will work. You can try it immediately. The problem is that in the real world, many things can go wrong because DEN can only signal that the server is willing to serve you, but DEN cannot guarantee that you have a clean path with the server. If you have a middle box, firewalls, etc., you're toasted. Also, if you use DEN, you don't get the data always from the DNS. You can get them directly from the TLS server through the chain extension. That's why currently the drafts recommend that you try TLS even before or just before looking up DEN because of the high risk of port 853 being blocked. I know that it is a deviation from the original idea behind DEN, so it may require discussion. Also, because for a long time, a lot of authoritative name servers won't have DNS over TLS, it will be necessary for the recursor to do some probing, for instance, to try 53 and 853 more or less at the same time in the spirit of the API eyeballs v2 RFC. Today, the draft mentioned that a resolver can operate in strict mode, requiring authentication, successful authentication, or opportunistic mode, where you don't have such a requirement. Of course, today, there are no authoritative servers with TLS, so strict mode is impossible today and will probably be unrealistic, unfortunately, for many years. So some people said that it should be dropped completely from the draft. I heard that the TLS working group decided that TLS 1.3, yes, it's really done, it's okay. So we may, for DNS over TLS, mandate its usage. This would require, working on this draft, would require rechartering of the group. You have seen the new charter proposed on the mailing list because the current charter only talks about the link between stub clients and the full resolvers. So the previous charter said that we may consider mechanism, but it's probably better to have a new charter. I support the proposal and so on. Unfortunately, we have a big problem because the first draft about this idea of a second stage of DPRIVE met very little discussion. I mean, there have been very few discussion, not even strong opposition. So I'm wondering, and this is something that we have to consider, if there is still interest to continue the DPRIVE working group, or if we lose steam after the success of the first stage. That's something interesting. And of course, we may have to update the charter if we want to do it. Otherwise, DPRIVE is closed and we can go back to something else. Thank you. Now discussion, Q, etc.
Ted Hardy speaking. Thank you very much for making the presentation. I note that you're concerned that you're looking for a mechanism to provide security here that relies on familiarity with the DNS rather than other mechanisms. I wondered if you had considered using the DNS challenge for the ACME protocol, which simply requires you to provision a specific DNS record to demonstrate control of a particular name, and then from there provision a standard TA certificate from Acme. It seems in many ways to be simpler, and the tool chains for Acme are definitely coming along nicely. So I wondered if you would consider that as either as a replacement or as an alternate.
I didn't think of it. There is something I really don't like in CA. It's the fact that if you don't find the record, you climb the tree up to the TLD, which means that .fr or .com could put a record used by all domains underneath. I always thought that it was a bad idea, but yeah, it may be something to consider.
Hi, John Dickinson. Firstly, I do support rechartering. And now for the bad idea fairy. I've been wondering, instead of using Dane to authenticate the servers, you already have keys in zones, and you could potentially, I guess, authenticate the zone rather than the server.
I don't get it because you can authenticate the zone, but what you want is to be sure that you talk to a server on that no one is snooping. So if you
well,
with keys in zone,
if the zone's signed,
yeah,
then can you not make use of the public key to authenticate that you're talking to?
But this is
correct
them.
zone?
I mean,
maybe, I don't know. It's just an idea.
Yeah, John Dane's doing functionally what you want already. This is Wes Hardiker, USC ISI. I like the idea of going this direction, absolutely. The one question I have is the happy eyeballs comment, because it sounds like you want to send it over the clear and encrypted at the same time. Is that really the goal?
Well, one possibility is to try happy eyeballs do not actually require that you send at the same time, but one just before the other, and with the hope that you get a reply. Because today, the problem, of course, if you send, if you wait a very short time and then you send the request in clear, you don't have any privacy. But today, because most of the authoritative servers, not most, all of authoritative servers don't support DNS over TLS,
yeah,
there is if you want to save latency, there is little choice. So I agree that it's bad for privacy, but that's a difference between strict and opportunistic mode, by the way. If you work in strict mode, you never try 53, but today it's simply impossible.
Let me give you a counter proposal, because if you use Dane, you can actually send a query for the DNS key and for the Dane record at the same time, and the Dane record could be used as a signal that that port should be open. So that will allow you to know by the time you get down to the point of processing the DNSSEC chain down to the Dane record, you'll actually have both of those at the same time, and then can decide where to send the actual real data request to.
The problem in opportunist mode, the problem with Dane is that Dane signals that you should be able to talk to the server, but in practice, and this is something that was often mentioned about DNS over TLS, that there is some probability that 853 is blocked. So even if there is a Dane record, you may be unable to talk to the server. And by the way, this is one of the reasons why DO was developed.
Jim Reed, Stefan, I'm sympathetic to the idea of having some kind of encrypted channel between resolving servers and authoritative servers. But in my opinion, it's very, very premature to talk about rechartering at this stage. There's so many other variables to consider. I think it's far, far too early to start on that work right now. First of all, we have very little in the way of operational experience with DPRIVE in its current state. There are only a small number of experimental servers set up for that just now. We don't have a great deal of operational insights into how to run these servers, what their impact is going to be, what their impact is on the end user, what the impact on the end users, plus we've got all this horrible policy group coming down the track with all these privacy considerations and GDPR. We'll have the same thing on the authoritative side as well. So that's a concern number one. Concern number two is there's other stuff going on in other IETF working groups, particularly in DO. And it looks as if there's a lot more momentum behind DO than there is beside the work in DPRIVE, in my opinion. So we should also take that into consideration too. I think a third very, very important point is we need feedback from the people that are operating these authoritative servers, particularly for routes and TLDs. Because if they feel that this stuff is going to harm the service they're going to offer, they're not going to deploy this no matter what. So we need some expertise about what would be the impact on this stuff, some modeling, some data, some testing, some analysis before we start down that path. So we've got at least an understanding of something that if we come out with something from this working group at some point in the future, there's a reasonable chance it's actually going to get picked up and used. And what I'm concerned about, particularly with this encrypted channel between the resolving servers and the authoritative servers, is we're opening up a brand new channel for really nasty DDoS attacks, in which case nobody can get service from the authoritative servers because they're too busy doing all the crypto.
Regarding the last point, first, I can switch my hat, can go from IETF participant to engineer at AFNIC. We operate authoritative name server for TLD. I discussed this, of course, a lot with my colleagues before presenting this, because I don't want to propose a draft that will create trouble for us later. The problem does not seem impossible. For instance, the last risk that you mentioned, we can have things like are already doing some authoritative server to have two sets of servers, one for UDP, one for TCP, maybe a third for TLS, and to use some front end like DNSDs to dispatch between them. So in that case, even if the TCP servers are completely dead, the rest will still work.
Yeah, but I'm just saying, hang on, before we go down that, we should try to get some data before we go down that particular path. We need to do some analysis. Yes, you can talk about these techniques, Stefan, and maybe they will work, maybe they won't, but that's not the point. I think before we start down that path, we should start down with the basis of some empirical evidence rather than saying, well, this seems like a good idea, let's go ahead and do it, which, okay, I'm exaggerating for effect, but that I think is perhaps the wrong approach to take here. And we should also bear in mind, I think, what was also said yesterday in Bert Hubert in the DNS working group said, we're adding a lot of complexity and a lot of the stuff we're adding to the DNS isn't getting used. So I think we also have to bear that in mind too, as a general principle, that if we add this stuff, is it actually going to get used in real life and will it make a difference?
All right, hold on. So I'm going to cut the mic line at Oliver, but keep in mind that we do have a charter item to talk about too. So some of the stuff is, if it's related to the rechartering, you can hold it till that. But so let's focus on the comments for Stefan's draft.
This is DKG. I support rechartering in this direction. Jim, I'm a little bit confused by what you said, because it sounded to me like you said we need more experience to see how these things work, and we shouldn't be working on them. And I think that by advancing a draft like this, we will encourage DNS operators to come forward and say, I did this and it worked, or I did this and it did not work, and here are the concerns that I have. And having the draft in an active working group with a bunch of operators in it is the way to get exactly the information that you're looking for. So I fully support working on this. I think it's a good idea. And I also think it's a good idea even for those recursive resolvers that are not doing DNS privacy to the endpoint. Like there's no reason that a recursive resolver today that isn't offering DNS over TLS or doing DOE couldn't use something like this to protect the queries on the upstream leg. So I fully support this work. We should be doing that.
Phil Hornbaker, I'm very skeptical. I'm skeptical. 99% of the time when our DNS resolver receives a hit, it's going to be served from cache. We don't wait. If the cache element is about to expire, we will refetch it before it expires. So the only time that we're ever doing authoritative to recursive, whatever, in response to a request from a user or whatever, is in the rare case that the element is not already in cache. So what we're looking at here is a fairly small subset of the traffic. And what we've also got to look at is, okay, I may not be able to see the bits on the wire because you've encrypted them, but the next problem that you have is the traffic analysis and leaking the information from the DNS server that you're directing to. And given the amount of effort that we have to go to achieve the encryption, I'm not sure that the privacy improvements that we get are justified by the number of attacks that are blocked by the encryption that are not blocked by traffic analysis. So I'm extremely skeptical.
For the small percentage of queries, I love to run TCP dump on the authoritative name servers, and I see a lot of requests on a lot of very private requests because many people don't use QName minimization. So I can see very long QNames already going in. So maybe this is only a part of the request, but it's an important part still. Now for the traffic analysis, we already have padding, and we could have other stuff like introducing arbitrary delays. That's costly, but or we could have gratuitous traffic to try to fend off analysis. But already with padding, we have already some a good way to address some traffic analysis issue, I believe.
Hi, Stephen Farrell. I guess I'd echo what DKG said entirely. I think starting work on this is a very good thing to do. I think, and albeit I think we should be doing all the things Jim was talking about whilst doing the work. So the only other thing I'd have to say is on the authentication issue, I'm not sure that so I think you were probably right to try and just pick a whole bunch of things to get people disagreeing with you. But on the authentication one, I think maybe the right thing to do would be to try out, do some tests on various different mechanisms and see what looks better after tests as opposed to just while writing drafts.
Yeah, this was what I suggested in the first draft before this one, but there was absolutely zero discussion. So
yeah, no, I think your tactic is good, but then I think that you should do the work.
Ben Schwartz. So I think that this is a hard problem, although maybe not so hard. There's a lot of consolidation of shared authoritative servers. So seeing the IP address of a particular authoritative server gives you less information probably than it used to about what name is actually being resolved or what subtree of names is being resolved. I disagree with a lot of the design choices in here, and that's fine. I think that's sort of an argument for chartering, for rechartering.
Ola Grimson. Thank you, Stefan. I think this is a topic we should be seriously thinking about. I'm not sure whether we should go forward with this document right now. I worry about the fan out from resolvers to authoritatives. We have a lot of authoritative addresses compared to how many resolver addresses are there. And so probably what I would suggest is we start studying a little bit more how we could coalesce connections into sites that host many authoritative servers and then scatter them locally. And I'm thinking of using possibly something like DNS dist to be the terminator. And so we need a protocol in here that we can tell it what address ranges to send on it. And that will also help defeat some of these traffic analysis that people are doing.
Chairs, I missed a comment that came in before you closed the mic line, but Sarah Dickinson had just said that, so I'm relaying for her. +1 to DKG's comment. She supports working on this now as the best way to understand the issues. And while I'm here, I'll say that Tony Finch said +1 to Ben.
All right, so while Tim pulled up the one slide we have for this, the slides refer to a Charter 2. I did send out a link to a Charter 2.1. Let's stick to Charter 2 because the only thing that's different between Charter 2 and Charter 2.1 was mention of a potential work item related to the BCP that we talked about earlier. So for the most part, what I want to focus on, you can look at the charter text if you haven't already, but in essence, it's really the work items that are probably going to be of most interest to people. We can wordsmith the charter to fit. So what I'd like to do is solicit comments from people who have either positive things to say, negative things to say, or questions about the text that we've thrown up on the GitHub. And we have
And I think we'll have to probably recharter slightly so we can actually start even studying some of this a little more in detail, which probably isn't a bad thing. And even if we say we want to recharter some, but we're not going to move forward on resolve it to authoritative till we have more substantive data, I think even the AD is probably okay with that. You know, I know when I spoke with Terry about this, we both felt that we could actually, if we rechartered, we would also be considering the idea that the whole thing would be an abject failure because we could get some authoritative service to work on it, but we could never walk the chain all the way to the top without a whole bunch of political stuff, right? So a lot of people, when they think authoritative, they think TLD root servers. And I start thinking about just people's authoritative zones as start there and start collecting that data because you're going to have to prove each step of the way, you know, will it work operationally, right?
All right, comment away.
Hi, I'm Shane Kerr. So these work items look good. I guess the thing is, it feels very much like we're in an experimental space here. I think we can all agree we really don't know exactly what the shape of a final solution would look like. We may need to add functionality to the DNS, which doesn't exist today, which is outside of the scope of this in order to get efficient operations and things like that. So while I'm very, very much in favor of having the work proceed of trying to encrypt or otherwise add confidentiality from the resolver to the authoritative side, it's not clear to me that it fits well in the IETF working group model. I guess you probably considered this, Terry, but maybe there's some better way to do this IRTF or just have independent researchers and developers work on it outside of this IETF.
Terry Manderson, responsible AD. Yeah, I thought about that. That's why I put in experimental on the second bullet point, just to start people thinking about how this could go forward, whether it's in the working group. There's always an option for an IRTF work area. I'm still just here to listen to what everyone here thinks first. I've not made any decisions. So I want to get a sense of really, is there willingness? How do people feel about going for various modes of attack on this sort of a problem?
Alex Meyerhofer. I have a similar comment. I'm happy with the first two bullet points. Yeah, that's fine. Also, experimental sounds very reasonable to me. The third bullet point, I think in agreement with what you guys said, I think we should push that to the IRTF, to the MapRG or somebody else. IETF working groups are not great at doing measurements, performance data. Maybe the definition would be in scope of the working group. But everything else about trying to gather statistics about operational issues, that's not the task of an IETF working group.
Petr Špaček, CZNIC. I very much support this work, and the proposal seems to be okay to me, at least the experimental part. And maybe I should reply to Stefan's question why there was a silence. At least if I speak for us as a not resolver developers, we just had full hands with the DNS over TLS from stop to recursive. That's not that we are interested in implementing or playing with ideas how to do recursive to off, but we just didn't have time before, right? So silence doesn't necessarily mean that there is no interest, just not enough hands.
Any other comments or ideas for this while we're here? Okay, so run, Matt, run.
Matt Ford. Just on the last bullet, the MapRG research group are actively soliciting input from IETF working groups where there is measurement work that they would like done. So that might be something you could consider.
Yep. We know the IETF chair, so we can talk to her, and she may have some good advice for us on that as well.
Yeah, and I know the MapRG chair, so
there you go.
Good shape.
So, we know people. So we'll take that as an action item to sort of to chat with them and solicit advice from them. And Terry, you seem fine with that as well? Yep. I figured. So, okay, that was great.
All right, so my esteemed co-chair actually put this charter up on GitHub. So if you have comments and or suggested changes to it, feel free to do a pull request. If you don't have a GitHub account and don't want to get one, then feel free to either post it to the mailing list or send it to the chairs. Any other things that people want to talk about in the 7 or 8 minutes we got left?
Wow.
All right, going once, going twice.
Great.
Enjoy the rest
I
of the
think we
week.
put Barry, we're done. You can sort of wake up now. So, thank you.
See you in Montreal.
Okay.